there everyone! Welcome to the second episode of the Weekly Roundup, the home of the latest and greatest in data science. In this week's news, we'll be looking at whether machine learning might be the answer to a centuries-old math problem, how researchers are accelerating synthetic molecule generation, and how Reddit created one of the most interesting data visualizations out of what was essentially an April Fool's joke. Our first story today takes a look at how machine learning might be able to solve a 250-year-old math problem. Since Euler proposed a set of equations to describe the motion of an ideal, incompressible fluid in 1757, mathematicians and physicists alike have been trying to blow up these equations by finding scenarios in which they completely break down. These scenarios, for example, a vortex that spins infinitely fast, or a current that abruptly stops, are commonly referred to as singularities, and have historically been very elusive. This problem is one of the 7 biggest maths problems of the millennium, as chosen by the Clay Mathematics Institute, and solving one of these problems would entitle the solver to a $1 million prize. So far, only one of the 7 millennium problems has been solved, and all manner of scientists still remain dedicated to trying to solve the remaining 6. The process of trying to find these singularities in the Euler equations has typically involved running simulations on computers, and looking at the approximate solutions the computer generates, to see whether they are in fact solutions to the equations. This technique of generating a computer-assisted proof is well established within the mathematical community, and has produced a solution to a very simple version of the problem. Another school of thought has emerged, however, after applying machine learning to the problem. A team of mathematicians and geoscientists is using deep learning models to approach fluid equations in a completely different way, and hopes to be able to find singularities for Euler's equations directly, instead of only being able to generate approximate solutions. Knowing that these solutions exist is often enough to apply physics to real-world problems. The path to discovering the solution to the Euler equations will not only help us to improve our understanding of fluids, but will likely lead to new mathematical discoveries and revelations. We can't wait to see whether machine learning manages to provide the last key to unlocking the secrets of Euler's fluid equations. Any of you who are interested in the specifics can take a look at the paper in the description below. In our next story, we'll take a look at how AI might prevent unnecessary waste in the automotive industry. Depending on the exact part, it's sometimes more efficient to remanufacture old vehicle parts instead of using them as scrap metal for recycling. While recycling involves breaking down parts and smelting them into new components, remanufacturing preserves the existing structure of a part and builds around it, without needing to smelt it down. Alternators and starters are examples of parts that are far more suited to remanufacture instead of recycling. The big difficulty, however, is in identifying and separating the remanufacture parts from the scrap metal. Oftentimes, the identifying tags or numbers on parts have been worn down and are no longer verifiable, making it difficult even for specialists to definitively sort them. The Fraunhofer Institute for Production Systems and Design Technology is solving this issue by developing an AI-based system that can identify remanufacture-eligible parts based on images of the parts themselves without relying on barcodes or part numbers. The circular economy is one of the drivers of sustainability mentioned in the Paris Climate Agreement, and research has shown that remanufacturing parts within such an economy could reduce automotive material consumption by up to 90%. Circular Economy Solutions, one of the partners in the AI development team, has estimated that around 9% of used parts that are processed are completely discarded because they can't be identified. Given that more than 7 million vehicles enter the recycling process each year, reducing the number of discarded parts would make a large dent in the ecological footprint of the automotive industry as a whole. Moving on to our next story, we'll be taking a look at an exciting new release from Databricks. The company is forging ahead on its growth path, having just announced the general availability of Delta Live Tables, the first and only ETL framework to combine both cutting-edge engineering practices and automatic infrastructure management. Let's break down what that means. ETL stands for Extract, Transform, Load, which is a way of describing the process of accessing data from various sources, making some changes, and then loading that data into one new destination. This process is a common pain point for firms working with lots of data, as it requires both high-level scarce skills as well as lots of tedious, complicated operational work. Delta Live Tables is Databricks' answer to this catch-22. It simplifies ETL development by uniquely capturing a declarative description of the full data pipeline, to understand dependencies live and automate away virtually all of the inherent operational complexity. It also enables data engineers to treat their data as code and apply modern software engineering best practices like testing, error handling, monitoring, and documentation to deploy reliable pipelines at scale more easily. Delta Live Tables fully supports both Python and SQL and is tailored to work with both streaming and batch workloads. This platform has already been implemented at some big companies like Shell, JLL, and Jumbo, and Databricks has now released a general version of Delta Live Tables to the public. The next story covers how researchers at MIT and IBM have helped scientists push the boundaries of chemistry by accelerating the efficiency of machine learning-based molecule synthesis. Generating new materials and chemicals is an important part of improving everything, from construction to medicine. Currently, deep learning algorithms are being used to propose new, manufacturable molecules with predictable physical properties. But these models require very large and very specific training data. In a new paper, a team of researchers from MIT and IBM have proposed treating chemical bonds as graphs, and then developing graph grammar based on this interpretation. Using the grammar and production rules that are inferred from a training set, the new model can not only reverse engineer its examples, but can create new compounds in a systematic and data-efficient way. The new method, which researchers have called data-efficient graph grammar, will be presented at the 2022 International Conference on Learning Representations, and the team behind the method has shown that it outperforms other cutting-edge molecule generating techniques by a large margin. In the immediate future, the team plans to scale this grammar learning process to be able to generate large graphs as well as to produce and identify chemicals with specific properties. This kind of research has applications in almost every industry imaginable, and we're incredibly excited to see how it's going to impact the scientific community. Our final story this week is about how Reddit users created one of the most fascinating visualizations of the year on Our Place, a massive online canvas in which each user was allowed to place one colored pixel every 5 minutes. Starting on the 1st of April and lasting for 4 days, the 2022 revival of the 2017 April Fool's joke saw more than 10.4 million users place over 160 million individual pixels. Our Place is a wonderful example of how data visualization has the potential to bring together communities and create meaningful experiences using very simple building blocks. Large subreddits like Our Ukraine and Our Star Wars began orchestrating their campaigns early, filling the space with a very large Ukrainian flag and several Star Wars movie posters respectively. Pixel raids were coordinated over platforms like Twitch and Discord, and communities banded together to protect their pixels, such as France fiercely defending their two flags and Osu fans protecting their round pink logo right to the end. Other noteworthy occurrences on the canvas include the repeated misspelling of Genshin Impact, the unexpected but wholesome alliance between Mexico and Italy, and Canada's extended struggle to draw a maple leaf. It's great to see visualizations bringing together people from around the world and emphasizing the power of online communities in an increasingly digital world. We'd love to hear some of your favorite moments and memes from the 4 days of Our Place, and you can take a look at the full time-lapse of the canvas using the link in the description below. That brings us to the end of another roundup. Thanks for joining us, and we'll see you next week.